So here I am your Arka sir. So I have come with my new episode and this is the first episode on current electricity. So if you can follow all the episodes of this topic, so I can assure you that the concept on this topic will be clear, and from starting level we will do the basic thing and slowly we will move to the advanced level. Okay, so if you want to see my previous all episodes I have uploaded, I covered at least 90% of light. Okay, where I have discussed about the reflection, refraction, lens, mirror, spherical mirror, okay, prism, all the things are uploaded. Okay, so subscribe my channel and also write in comments. Actually, if you want to get the quality notes, okay, then also you let me know. And if you have any doubt or if you want to see any special episodes on any special topic on physics or biology, okay, then also you can write it in the comments. I'll try to upload that. Okay, so comment that. Okay, what you want, that will inspire me. So now let us start about the current electricity. So what is the current electricity? Okay, current electricity means, see, inside the first, when a charge electrons, when the electron, there is a flow of electrons, then only the current electricity exists. Okay, so our electron flow should be there, the flow of electrons should be there. Okay, suppose the electron is flowing from A to B, then the flow of current will be from B to A. So the direction of the current will be opposite to the direction of the electron. Okay, so now before we start, we have to understand the three things. First one, three type of materials are there. First one is known as conductor. Okay, second one is known as insulator, and third one is known as semiconductor. So this part only, what is semiconductor, that I will discuss here, but this part we will discuss in detail when I will teach you the modern physics. Okay, so these three type of materials are there based on how they can conduct current, okay, or heat to themselves. Okay, how they can conduct it. Okay, so based on that, the three type of materials are there. So now basic thing is the conductor. What is the conductor? Conductor means the material, those who allow the current to flow through it. Okay, that are known as the conductor. Basically, most of the metals are very good conductor, just like aluminium, okay, or copper, okay, or silver, okay, so or silver, okay. So these are known as the gold. These are known as the conductor. So the conductor are the material which allow the current to flow through it. What is insulator? Insulator means the material which don't allow the current to flow through it. Okay, very simple. The materials, okay, which don't allow the current to flow through it, those are known as insulator. What are the examples? Glass, okay, glass, then plastic, okay, plastic, then what? Rubber, okay, rubber. So these are known as, okay, insulator. Okay, so it don't allow the current to flow through it. Okay, so these are known as insulator. Now next one is what? Semiconductor. Semiconductor means what? In the normal condition, it cannot carry the current through it. But if we supply some heat from supply some energy from outside in form of heat or light, then it can conduct a small amount of current through it. Okay, so these are known as semiconductor. That means in normal condition they will behave just like an insulator. But if we supply some energy from outside in form of heat energy or light energy, whatever, then it can conduct a small amount of current through it. So these are known as a semiconductor. The example is what? Silicon, germanium, okay, then diode or triode valve, okay, triode valve. So these are basically the examples of the semiconductors. Okay, so that we will discuss. N-type, P-type semiconductors, doping, all the things are there that we will discuss Okay, later on. Okay, when I'll teach you the modern physics. Okay, so now, we now come to know about the three type of materials, that is conductor, semiconductor, and insulator. So conductor can carry current and heat through it. Semiconductor don't allow the current to flow through it or heat to flow through it, and the insulator in normal condition they cannot conduct current through it, but if we supply some heat from outside they can conduct a little bit current, a little amount of current through it. Okay, so these are known as semiconductor. So basically what happened, some free electrons are there which are responsible to carry current through any material. Okay, now basically one theory is known as, that is known as the band theory. Okay, so in case of the conductor, okay, basically three type of things is there. One is known as full band, another is known as valence band, and another is known as conduction band. So in the full band, what is happened? Three layers are there of the electrons. Okay, in case of any materials. So in the full band, the electrons which are tightly packed with the nucleus. Okay, that means they cannot take part in any chemical reactions. Okay, it's very difficult to take the electrons out from their orbit. Okay, so these are known as the full band. So that electron cannot be taken out from the orbit easily. Okay, so and they do not take part in any chemical reaction. So these are known as the electrons. Okay, total number of electrons are forming one band or one energy level, that is known as the full band. Okay, the electrons in the valence shell, okay, those who will take part in the chemical reaction is known as the valence band, and the electrons which will come out from its orbit and can conduct the current, electricity through any conductor, those are known as the conduction band. So if any electron can be transferred from valence band to conduction band, the electron cannot be transferred from full band to conduction band. Okay, the electron can be transferred from valence band to conduction band. If any electrons are there in conduction band, so those electrons, conduction band, that means they can conduct current. That's why it is known as conduction band. Okay, so if any electrons are there in this conduction band, so that electrons is also known as free electrons, and that electrons can conduct current through any materials. Okay, now what happened in case of insulator? It is for insulator. In case of insulator, so it is what? It is full band. Now at the top level of the full band, what is there? Some electrons are there, it is known as conduction band. And at the top, it is valence band, and it is conduction band. So see, the energy gap between the valence band and conduction band is known as forbidden gap. Okay, so see, in case of the insulator, the energy difference between the valence band and the conduction band is huge. Okay, or it is known as forbidden gap, is huge. That means it is almost impossible to shift any electron from valence band to conduction band. It is not possible, almost impossible to shift an electron from valence band to conduction band. So no electrons are there in the conduction band. Okay, as the forbidden gap is huge, so no electrons are present in the conduction band. So who will conduct the current? No one. Okay, because the free electrons can only carry the current. So from the valence band to conduction band, no electrons are. It's not almost impossible to shift an electron from valence band to conduction band in case of insulator, because the forbidden gap or the energy differences between the conduction band and valence band is huge. Okay, that's why it is not possible, almost impossible to shift an electron. That's why the insulator cannot carry any current through it. Okay, cannot carry any current through it. The insulator. Clear? So now the insulator cannot conduct current through it due to this reason. So all of you clear? Now let us draw this diagram for conductor. Now let us draw this diagram for conductor. So first this band you can say it is known as full of electrons. Okay, closely packed with the nucleus, so it is known as full band. Okay, at the top of the full band, what will be that? It is full of electrons. Some electrons are there. Okay, it is known as valence band. Valence band. And there will be the overlapping of the between the valence band, and it is known as conduction band. So see, in case of this is the overlapping, okay, overlapping area of valence band and conduction band. Okay, so see here no forbidden gap is there. That means the valence band and the conduction band will overlap with each other. Okay, it will overlap with each other. That's why the electrons in the valence band will act as a member of conduction band also. That means in normal condition, a number of free electrons are available in the conduction band, because electrons of valence band will act as a member of electron of conduction band. Okay, that means in normal condition, a number of free electrons are available. So these electrons are responsible to carry current through a conductor. Clear? So that means what? I am explaining once again. In case of the conductor, the full band is full of electrons. We don't have to think about them because they are useless for us now. Okay. So we have to think about the conduction band and valence band. Clear? And the conduction and valence band are overlapped with each other. So overlapped with each other means what? The electrons present in the valence band will act as an electron of the conduction band also. Okay, because both are now overlapped. So a number of electrons are available. Okay, in the conduction band. So those electrons can carry current through it in normal condition. Okay, so that's why these are known as conductors. Okay, almost all the metals are very good conductor of electricity. Okay, so I hope you have understood this. So this diagram is also very much important. Clear? Why the conductor can carry current, why the insulator cannot. So this will be the answer. Now let me talk about insulator a little bit now, details in later. Okay, so now insulator, semiconductor. Okay, a little bit I will discuss now. And details I will discuss when I will teach you the semiconductor devices, diode, triode, transistor, okay, thyristor, all. Okay, in case of modern physics. So it is known as full band. Okay. So at the top of the full band there is what? Valence band. There is valence band, and here will be what? Conduction band. So you can see the forbidden gap. It is what? Forbidden gap. So you see the gap, energy difference between the conduction band and the valence band is not huge like the insulator. Okay, the energy difference between the conduction band and the valence band, or the forbidden gap, is not huge as compared to the insulator. That means in normal condition we don't have any electrons over here. So in normal condition it will behave like an insulator. But if we can supply some energy in form of light, in form of heat, okay, in form of anything, if we supply some energy, then some electrons may be shifted here. Some electrons may be shifted from valence band to conduction band. So what will happen? It will also get some free electrons in conduction band, and those electrons will be responsible to conduct current through it. So after supplying some energy, some electrons can be shifted from valence band to conduction band for semiconductor, as the forbidden gap or energy difference between the two bands is not huge. Okay, so some electrons are possible to shift from valence band to conduction band, and those electrons can carry current through it. Clear? So this is known as the semiconductor. Okay, so in normal condition, no electrons will be there in conduction band, but if the energy difference between the valence and conduction band is not huge, that's why a small amount of electrons can be shifted from valence to conduction band by applying some energy from outside, so that conduction band can get some electron, and those electrons can carry the current through it. Clear? So this is the three type of materials: conductor, insulator, and semiconductor, and why they can carry current through it I have discussed. Okay, so hope you understand this. If you have any doubt, any queries, you can write in comments. Okay. Now, what is current? What is electric current? Okay, or what is current electricity? Okay, or flow of electric current. Okay, so see, suppose this is a conductor. If the electrons are flowing, through the conductor, okay, or charge is flowing through a conductor, then what? The current electricity will develop. Okay, so what is the definition? The amount of charge flowing through a conductor to a unit cross sectional area of conductor in unit time is known as flow of electric current. Okay, that means what? So suppose we are taking a unit cross sectional area. Suppose this is the unit cross sectional area of this conductor. Okay, so the number of electrons, the amount of charge flows through it in unit time, that means in 1 second. Okay, unit time in 1 second. So that is known as the flow of electric current, okay, through this conductor. Okay, the flow of electric current through this conductor, and the unit of this is ampere. The unit of flow of electric current is ampere. It is also expressed as capital A. Okay, that is ampere. Clear? So what is flow of electric current? Is the amount of charge flows through the unit cross sectional area of a conductor. Unit cross sectional area of a conductor in unit time or 1 second is known as flow of electric current. Okay, so the unit the amount of electric current, unit of amount of electric current is Coulomb. What is Coulomb? I will describe later on in details. Okay. So ampere. So what we can write? Electric charge, electric or flow of current, flow of electric current, electric current. I is equal to what? Q by T. I is equal to Q by T, where Q is equal to amount of electric charge and T is equal to time. So how we can now define ampere? Okay, very easy. So ampere A is equal to Coulomb by second. Okay. So that means what? If 1 Coulomb of electric charge is flowing through a cross sectional area 1 meter square in 1 second, then flow of electric charge is 1 ampere. Okay. So that is the definition of ampere. So all of you have understood what is ampere. So suppose this is the conductor. Okay. The electrons are flowing through it. Okay. So if 1 coulomb of electric charge is flowing through a unit cross sectional area, we have assumed it as 1 meter square. Okay, in 1 second. So that is known as, then the flow of electric charge through this conductor is known as 1 ampere. Clear? So it's very, so ampere I is equal to Q by T. Okay, ampere, so Q means amount of charge and T means second. So if in 1 second 1 coulomb charge is flowing through unit cross sectional area or 1 meter square area through a conductor, then the electric flow through that conductor is known as 1 ampere. Okay. Now the next point. Potential and potential difference. Potential difference. Okay. Potential and potential difference. Before discussing the point, we have to understand what is electric field. Okay, what is an electric field? Suppose any charge is there, so there will be the area around this charge particle where the effect or the influence of the charge particle can be observed or can be seen. That area, suppose a magnet, suppose I have kept one magnet. Okay, so what? There will be an area around the magnet where the effect of the magnet can be seen. Okay, that means if we bring any piece of magnetic material over here, it will be attracted by the magnet. Yeah. So the area is there around the magnet. That area is known as magnetic field. Okay. And here for any charge particle, okay, if we keep, then the surrounding, there will be an area where the influence, the effect of the charge particle can be seen. Okay, so this area is known as the surrounding area of that particular charge particle where the effect of charge particle can be observed or can be seen is known as magnetic field. Okay, for that charge particle. Now, there is a theoretical definition. What is the theoretical definition? from infinity. From infinity. Okay. Actually, what is potential? How you can understand? Suppose let us consider about the, okay, suppose this is a tube. It is full of water. Okay. And it is a pot which is also full of water. Clear? But its height is lesser and the height of the water column is higher. So if we connect a tube, okay, if we connect a tube between this water pot and the tube, okay, okay, then it is a glass tube, it is also a tube, okay, it is full of water and it is a water pot, okay, or the bucket you can say, which is also full with water pot, okay, sorry, water. Now what will happen? As the level of water height is here greater than this, so the water will fall from what? Here the amount of water is more, here the amount of water is less, but still as the height of the water column is higher over here, so the water will fall from this glass tube to the bucket. Okay, though the amount of water in the bucket will be more than this, but still the water will fall from the higher to lower. Okay, so that is nothing but you can compare it as potential. Okay, the potential may be compared to the height of the water column. So from higher potential to lower potential, the electric charge will flow. Okay, the current will flow, or that will be the flow of direction of the current. Okay, so from negative to positive potential, okay, the electron will flow and the current will flow to the opposite direction. Okay, so you understood what is actually potential. The potential actually define which direction, from which to which point the current will flow. Okay, just like the water column. Okay, now the thing is that there is a traditional definition. Suppose this is the area of electric field. Suppose it is the electric field. Electric field. Okay, suppose the electric field. And distance infinity. Infinity means we cannot measure. Okay, there is a unit positive charge. Okay, unit positive charge. Okay, 1 unit. Okay, the positive charge is there. It is placed at infinity. Okay, so now suppose this is, I am considering only one point in this electric field. One point at any position. Okay, it may be at the middle, it may be at the top, it may be in between, anywhere. Okay, so unit positive charge from it is in infinity. It is at infinity. Okay, so a unit positive charge we need to bring over at this point A, inside the electric field. Clear? So the work needs to be done to bring a unit positive charge to this point. Okay, is known as potential of this point. Okay, in that particular electric field. Clear? So what is the potential of a point in an electric field? So if we want to bring a unit positive charge from infinity to that particular point inside the electric field, then the work needs to be done. It's known as the potential of this point, okay, inside that electric field. Clear? So I am explaining once again. If we want to bring a unit positive charge from infinity to a particular point inside electric field, then the amount of work needs to be done is known as the potential of this point, okay, inside the electric field. Clear? So this is the definition of potential. Now what is potential difference? What is potential difference? What is potential difference? Okay. Suppose this is electric field. Inside electric field, 2 points are there. Okay. So a unit positive charge we want to bring from this point to this point. So the amount of work done, okay, to bring a unit positive charge from one point to other point inside the electric field is known as potential difference between these 2 points. Clear? So if we want to bring a unit positive charge from one point to other point inside an electric field, then the work needs to be done is known as the potential difference of that 2 point inside that electric field. Okay, so this is the potential and potential difference. The SI unit, the unit of potential difference or potential, okay, difference is known as volt. Okay, the unit of potential difference is known as volt. Clear? So this is known as the potential difference. Now Ohm's law. Okay, it's a very common thing, Ohm's law. You will learn it in board exam, you will learn in class 12 board exam, you will learn this application of the law and the law in engineering in graduation level also. It's a very common thing. Clear? Ohm's law. Suppose AB is the conductor. Okay, AB is the conductor. Okay. Okay, AB is the conductor. So the potential at point A is what? VA, and potential at point B is VB. Here we are assuming VA is greater than VB. That means from higher potential to lower potential, the electric current will flow. So the electric current will flow from A to B, and the electron will flow from B to A. Clear? Now say VA minus VB is equal to B. Okay, the potential difference. Okay, and the current flowing through this conductor is I. Okay, current flowing to this conductor is I, and the potential difference between the 2 points is V, and the current is flowing from A to V. Now temperature, and if temperature, now what is Ohm's law? If temperature and other physical condition of this conductor remain constant, that means we are not changing anything. Clear? Temperature is constant and other physical conditions of this conductor is constant. Okay. Then what will happen? The current flow through this conductor will directly proportional to the potential difference across the 2 points of the conductor. Okay. So this is Ohm's law. I am telling once again. If temperature and other physical condition for a conductor remain constant, then flow of current through the conductor will be directly proportional to the potential difference across the 2 terminal or 2 points of that particular conductor. Okay. That means if the potential difference is higher, then more amount of current will flow. If the potential difference is lower, less amount of current will flow. If there is no potential difference, no current will flow. Clear? So that means what? It will depend on the potential. What amount of current will flow from one point to other point through a conductor will depend on the amount of potential difference. If it is higher, more amount of current. If it is lower, less amount of current will flow. If no potential difference is there, no current will flow. Okay. So now what we can write? V is equal to I into R. Okay. So we are now omitting the proportional sign. So we have to bring one constant where R is equal to constant. Okay. R is equal to constant. This R is known as what? R is known as resistance of the conductor. Resistance of the conductor. This R is known as resistance of the conductor. So what is R? R is equal to V by I. Okay. R is equal to what? V by I. That means if the question comes, define resistance of a conductor. Define resistance of the conductor from Ohm's law. Okay. From Ohm's law, define the resistance of the conductor. Then what we can write? What we can write from Ohm's law? If we have to define the resistance of the conductor, then resistance of a conductor can be defined as the ratio between what? Between the potential difference across 2 points of that conductor to the what? Flow of current, flow of electric current between that 2 points. Okay. So that is the definition of resistance of a conductor from Ohm's law. Okay, from Ohm's law, this will be the definition of resistance of a conductor. What do we know from Ohm's law? V is very just I by just V. Therefore, V is equal to I into R. Okay, so R is equal to what? V by I. So now the resistance of the conductor V is nothing but what? The potential difference. Okay, and I is the flow of current. So the resistance of a conductor can be defined as the ratio of the potential difference across the 2 points of a conductor to the flow of current between that 2 points of that conductor. So that is known as the resistance of the conductor. There is a general definition of resistance of the conductor. The general definition is there of the resistance of the conductor. Okay, what is the general definition? It is the property of a material due to which it opposes the flow of electric current through it. Okay. So what is the resistance of the conductor? General definition. If the current is flowing through any particular body, then what? The property of that particular body or material which opposes the current to flow through it. That property is known as resistance of the conductor. Clear? So that is the general definition of resistance of a conductor or an insulator. The insulator of high resistance. Okay, that's why it opposes the total flow of current. The current cannot flow through it. the conductor offer less amount of resistance. That's why what? The current can flow through it. Clear? So, if the resistance of the conductor is high, less amount of current will flow through it. Okay, and if it is low, then what? Great amount of or more amount of current will flow through it. Okay, so this is the normal definition of resistance. The unit of resistance is ohm. It is also like this side. Okay, the unit of resistance is ohm. Clear? So, students, so how I have discussed about the Ohm's law. Okay, how we can get the definition of resistance and what is conductor, insulator, semiconductor, why they can conduct current through it. Okay, in band theory. Okay, I have discussed in this episode. So in next episode, VI graph. Okay, as well as we will move to the resistivity. Okay, and different type of circuits, electric circuits. Okay, combination of resistance. Okay, equivalent resistance. Voltmeter, ammeter, everything. We will move to the core. Okay. So I hope this concept is clear to you. Okay. If you have the patience to go through the topic from the beginning to end. Okay. I will be very much sure that this concept will be very much clear to you. That's why it's my motto to give these informations to you so that the subjects you will feel a very easy thing. Okay, it's not a very difficult to understand. So write in comments how you enjoyed this episode. See you next. Thank you.